Asia Times, and it's my pleasure to welcome you to the revolution. We're in the midst of one of the great changes, epochal developments in human history, as important as the introduction of the steam engine, the electric light, or the computer. This is the fourth industrial revolution, and Asia Times is deeply honored to host two revolutionaries, two of the frontline practitioners of the new industrial technologies that will leave the world in a very different state than we're used to. Dr. Maximilian Dormemuth is the head of the Bosch Rexroth Training Institute. Bosch, of course, is the world's premier engineering firm. He's also a lecturer at the University of Karlsruhe and previously was the global head of the digital transformation program of Bosch worldwide, working in 49 countries. Paul Scanlon is an advisor to the CEO of Huawei, the world's largest manufacturer of telecommunications infrastructure. Previously, he was Huawei's chief technology officer. And between the two of them, I think we're in for an extraordinary narrative. To abuse my moderator's privilege, I'd like to mention that last month I visited China for the first time since the COVID epidemic, and I saw things which looked like they were out of a science fiction movie. So, for example, in Tianjin, one of the world's 10 largest ports, the port of Beijing, automated giant cranes run about communicating with each other on 5G networks using artificial intelligence algorithms to empty giant container ships in less than an hour, pluck out the containers, put them in autonomous trucks which run around driverless, and send them on to their ultimate destinations. It stretches on forever. It's gigantic. There's nobody on the longshore except a couple of repair people. And the point of the port is that it itself is the big export item. So what we've seen in automation of factories, of ports, of warehouses, and many other functions, it's more than the demo version. We have working transformations using AI and high-speed broadband, which allow us to do things that we never did before. My first question to our panelists is, now that we have the prototypes, now that these things are up and running, what will it take to get large-scale adoption of these technologies? How fast will that occur? What do you see happening? Dr. Dormemuth, would you like to start?
Yeah, sure, I can do this. So, hello, everyone. Technology is great. I love technology, and Bosch, it's also a technology company. And I think we do a lot of good progress if you look into pilots and if you look into working on ideas and getting these running. So I think we have really, really great examples around the world, what we are doing currently. Unfortunately, to transition these topics into a new environment or to copy that, it's really challenging because the environments in different countries, also in different regions, are not the same everywhere. So maybe I start with an example to show you what I really mean. So normally people love technology. So it's like with the latest innovations with smartphones also on. And if you imagine a senior manager from a plant going to a fair or somewhere where he sees new technology, he sees it and he thinks, wow, that's great, 5G, artificial intelligence, augmented reality glasses, that's really great. I love it. I want to buy it. I saw it there. It was so special. It was working. I want it now in my company. So what he probably doesn't imagine about is that there is much more necessary than just technology. So it's like if you compare it to a car, if you don't buy a new plant, So you also don't buy a new car, you tune your car, you ramp it up, you give it new technology. And so you're sitting in a modern cockpit thinking you have the dashboards, you have your visualization you need, you have all the technology you need to do autonomous driving and so on. And then you try to push on a throttle, you try to accelerate, and what you see, the car is not moving. Your company is not moving. I bought the newest technology. Why isn't the company moving? Why doesn't happen anything here? And then you get out of the car and you see, oh, I am missing tires. I don't have the IT infrastructure, what I need to do this. Oh, I am missing fuel. I don't have the data I need to do these topics. Oh, I am missing, everything is rusted through. I don't have the people. I don't have the qualification to get these things running. So what I want to highlight is technology and implementing technology is much more than just technology buying. It's organization, it is strategy, it is qualifying people, and so on.
That's a terrific point. Paul, would you like to jump in?
Yeah, thanks, David. I think we might have a bit of echo on the line. But I like to start from, let's have a look at what's happening in the world. Okay, so the world is moving more towards circularity, sustainability, and reduction of greenhouse gases, right? So all of this is fundamentally about efficiency. Yes. So I'm coming back to the drivers, the reason why we want to do all these things, the examples that you mentioned. And if we just think about Industry 4.0, then that's all about productivity and efficiency. That's where we're starting. And if we have a look at, say, what happened in China, in a year, the mobile operators are making about 1.3 billion US dollars out of solutions, just like Max is talking about, right? Precisely these components of the productivity improvements, etc. But the reason we're not getting the traction, as he mentioned, have a lot to do with mindset. Yes. But the good news is, if you look at what GSMA said, GSMA's already done some studies and they find about 10,000 private 5G networks across the world. So you've got China, who's been developing a lot of these use cases, as you saw. And, you've got, I'll say, the start of some of this adoption of technology like 5G and also cloud-based AI solutions, yes? But the challenge is really the DNA of the company. So then you ask the question, why is it happening in China, apparently on steroids, and we're just slowly taking off in the rest of the world? A lot of this has to do with not just companies' DNA, but also the way government and government incentives. But fundamentally, the bottom line is, do people really understand how to execute? And that's really the challenge we have here. How do you execute, right? What you can do in country A, you can't necessarily do in country B. And remember, when Max mentioned about 5G networks, the 5G networks are generally built, other than some of the private networks, generally built by the telecom operators. And for the last 30 or 40 years, we pay a lot of money for license, we pay more money for network, and we build towers and we sell SIM cards. And now the telecom company has to go to Bosch and say, oh, I know all about manufacturing. I don't think you know manufacturing better than Bosch. Or go to the hospital and say, I know how to transform your healthcare system. These things are not as easy and as straightforward as you might think. So the scaling is the challenge. So then why does that happen in China? Why is some of these things happening, an example, in Thailand? Some countries understand, as you said, don't fear technology. I mean, new technology transforms industries and societies. That's what we've seen across all the industrial revolutions, right? That's exactly what it does. So how do we demonstrate how it can be done in a culture, because it is about culture, not just culture within a country, but culture within a company, an ecosystem of partners of collaboration. Huawei doesn't do it by itself. China Mobile doesn't do it by itself. Bosch doesn't do it by itself. So we're talking about something rather complicated here.
Professor Dommermuth, let me ask a related question. When we talk about industrial automation, we think of very large enterprises like the auto industry with enormous capital base producing very large numbers of units. what do these technologies mean for small and medium manufacturers? Is this something where you're only going to have 20 customers, Volkswagen and Mercedes and Continental, or will you have thousands of customers? Will this be something which will make life easier or harder for medium-sized enterprises, the famous German Mittelstand of manufacturers?
Well, that's a good question. So I can be really happy working at Bosch because we have different business models. So there's the automotive, mass production, few customers. And we have, for example, units like Bosch Rexroth. We have 1.2 million different products. And we have probably 30, 40, 50,000 customer above. And that's a different thing of doing it. But in the end, if you think about infrastructure, if you think about strategy, if you think about scaling up your processes, it is quite similar. So it's not like this that you can only do it if you do mass production. The challenge is another challenge. So you have started with mass production. So this was Taylor, Ford, you know them in the past revolutions. What did they do? So they did the same product a lot of times, so they get more and more productive, more efficient. And now what's happening is that customer decide what to buy. You cannot say you have to buy it. The customer says, I wanted something different. I want it in another color. I want to have it something else. So now you have to start making smaller lot sizes. So you don't have the huge lot sizes. We have lot sizes like 5 parts, even 1 part. So our major lot size is 1.3 parts here at Bosch Rexroth. So that's not much. And that means you have to have good processes where you can automatically set up your production line and you automatically set up your work plans and so on and so on. So this means in the end, you are more dependent on clever solution, good data and good processes when you do smaller lot sizes instead of doing big things. And if you could look at German Mittelstand, there are also different types. There are big lot sizes, there are small lot sizes, but the more you go to small lot sizes, the more necessary it is to have a good data set in your back so that it automatically can set up things. If you have to do this manually, well, that's a lot of effort. You cannot do this.
It's a
maybe I take up on that point. I was just thinking to take up on that point, but yes, carry on.
Go ahead.
Yeah, well, what Max was saying is absolutely true. In fact, we see an example of this almost, I'll say, just in time for the smallest possible unit, the ultimate in flexibility in manufacturing, yes. And that's actually one of the use cases of this thing we call 5G, or whether it's 5G or Wi-Fi 6E or fiber. But the point is it's highly connected everything within an ecosystem, and then huge amounts of data that are appropriately analyzed by some form of machine-based learning or AI. And the objective is to make it as efficient as possible, right down to one. You only need to make one. But in terms of the organizing the factory, the robots, when to start them, when not to start them. And, we have examples of this, which we've done in China Mobile. We've done it to many factories in China, where we've gone from these, I'll say, very classic serial processes, whether it was a person spinning cotton and making a jumper and passing it from me to you, or robot A passing it to robot B, passing robot C, where now you almost have Lego blocks everywhere, self-organizing to try and make any type of product for anybody. But what we just started with was, hang on, we wanted the world to become more circular, more sustainable, more green, more efficient. And we want productivity improvements. And they're almost conflicting in a way, yes? So the bottom line, what you do get out of these types of technologies is efficiency. And what you've just mentioned, Max, about the Mittelstand in Germany, one of the key things that I really like about it is, the governments back them because they want them to be innovative. They're globally renowned, okay, this sort of very thick middle layer of capabilities, 2.63 million odd companies, right? And so they're innovative. They want to adopt technology. But the challenge is, how do we scale these things? So we've got these examples of factories which we've done in China. We've got examples of just take healthcare, right? Where we deploy things like a big Pangu model, that we have an AI-based model, and we deploy it in hospitals in China. We've managed to deploy them in example Thailand. The government gets it because the government has a requirement to try and move, I'll say foreign healthcare, the tourists' healthcare, but it understands the benefit of having this massive efficiency that an AI generates because you have few experts going to the masses. And it's the same thing you have here, whether it's, robotics or not robotics, trying to get those sorts of efficiencies, the same in mining. So these are the challenges that we have. But, Dr. Dhammamuth, you're absolutely right. We have a challenge if we want to scale everything right down, yet we want to scale the use cases all the way up across the world.
Let's talk for a second about, sorry, go ahead.
Yes, just one thought on this. So you're definitely right. Yeah. It works because we have standards. In the end, this means 5G is a standard, Wi-Fi 6 is a standard. So it works everywhere because it is defined, but not everything is defined. So let's take the topic digital twin, for example. So you have a real product, physical product, and you want the twin of it. It has to be digital. You want to know what happened, everything to the physical product, and you have a digital twin. And what we start in Germany, it's often pushed in from Germany side. We did the asset administration shell. So this is a global standard we are currently working on to define which assets there are, which data layers are in an asset to define. So I don't want to get too much technical, but that you do every definition. So we don't care which provider you are. You do it in a certain way of standard, and we can easily implement your products, your tools, your technology, because we are following a certain standard. And this, for example, in the digital twin case means in the asset administration shell, we can just replace something and it works afterwards without a lot of application needs afterwards that it gets run. You just switch your tools in the hardware in the industrial sector and it works. And this is, I think, a special example and a good example where the road is going, where we are going towards what's happening. So we try to be provider independent and have more alignment so that it's more easily for a company to integrate new solutions and to maybe also change a solution. Maybe today it's great, maybe in 5 years there's a new way to do this. Why should we be set and stuck in the old ways how we are doing it? And this is maybe one of the major parts I think it needs to be successful also.
Let's, instead of looking at this only from the firm view, think about stakeholders, consumers, shareholders. One example, which of course pops out of the headline this morning, is the Chinese auto company BYD, which reported more than doubling of profits in the second quarter, despite a price war in the electric vehicle segment, which is its main business. BYD introduced an $11,000 compact EV. It looks to me something like the Model T of the 21st century. And despite lower prices, they managed to make money. Do you see benefits coming to consumers through cheaper industrial projects and benefits coming to shareholders through higher profitability? And how fast is this likely to happen? And where should I put my money?
Well, I think this is also not so easy to answer, but I think that's the case of the discussion anyways here. So in the end, you always cannot be more efficient and more efficient and more efficient. There's always there is a limit. So if you do a lot of units, then you can get a lot of more efficiency out of your working plans, out of your topics you're aiming for. Do you do a price war? Don't you do a price war? What's the right strategy? What do you really need in a car? Is it in the end a software upgrade? You do like software as a service in the end, and there you get your money because you say your latest navigation or your latest update for autonomous driving. There you just buy an app or whatever. So it depends on your business model. If you are just selling hardware in the future, I think you won't have the chance to be the leader in the end. You need to have partners. You need to work with them together to have a seamless way of enjoying what you buy. For example, the customer, I buy a car, I can see how much it is charged. It tells me it would be clever to do a charging now, because then you could save time, because there's a rush hour anyway, so please do that. So this is the whole customer journey. It's not just the product, it's a lot around the product. So I think, first of all, for the customer, it's necessary to be integrated into your ecosystem, what you are using, and this is really a benefit for the stakeholders. I think pushing topics which are paying into needs of the world or of the countries is always clever. For example, you say electric vehicles. So this means you need the charging infrastructure and so on. If you have everything there, that's great. That means you can now push topics for sustainability. Then you will learn, oh, not everything in sustainability I can do with technology. Maybe it helps to say there's a speed limit. I don't say this for Germany. I'm a German Autobahn driver, so maybe do it somewhere else. But in the end, you have to think about clever ways of reducing energy and to do sustainability. Why don't we use the energy? What's with smart grid? How do we want to do it? So there are different approaches where you can really drive towards topics everybody needs. And if you are working on, for example, you had the example electric vehicle. If you work on topics which the whole world currently wants, you are on the right path. So it's just the needs which are there.
Yeah, good.
Well, going back to Maximilian's remark about the need to make sense of this technology, I know Huawei has done a number of things in high profile to try to make it easier for firms to use artificial intelligence. You have a system called Pangu, which is, from what I understand, is like the do-it-yourself approach to processing your own data and making your own applications. How do you see these ideas propagating? From your experience talking to customers, that was Maximilian's original point. What will it take to get very fast adoption of technologies which to most of us look like science fiction?
No. So I think there are 3 points there, David. The first one is directly to answer your question, but following up on the two things that Max, you just finished with about, just energy efficiency, yes? So just take some examples about that feedback, where you said, if we knew how much energy, would we change our behavior? Yes, for example, yes. And a classic example would be, I'm about to turn on the dishwasher or the clothes dryer, and the system either won't allow me, or it'll tell me it's not the best time because the energy is not green. Best way is it's too expensive, right? But it's not green. For example, it's not renewable. But just take that particular concept. An example of innovation that Huawei had deployed just in our 4 and 5G base stations is the ability, using AI, to monitor the traffic and the behavior of consumers. So we just start with the consumers at a cellular level, and then we can adjust the power transmission and capacity and other parameters so that we're actually not consuming more energy, electricity, than we need based on the profiles or about the profiles that are, customers are, the customer profile over that time period, even down to zero. If it's, there are no customers there, there's no traffic, or we hand it over to another cell, for example, or a different frequency because it's more efficient. So we're looking at this type of feedback loop that's done at the cellular based on consumer demand. Yeah. And then to take the example that you've just mentioned about Pangu, and what does Pangu do? Pangu really has two key components to it. One is we're using the Ascend chips in a cloud, yes, and on the servers. And the second one is we pre-train the models. So, we have models that do everything from, okay, we started with obviously with mining, manufacturing, mining, but drugs, just take drugs. Over the course of a year or so, we've trained this thing on we've decoded 100 million naturally occurring compounds. Then it only takes you about 6 weeks to do a match on, disease and drug. And by the way, that's not really a drug, it's a naturally occurring compound. So suddenly the cost of the drug is 70 to 80% less. Yes. And the next point and we do this across, multiple things, not just mining and drugs, etc. I mean, railway, with the railway, the rolling stock, just take freight trains. So we take millions of photographs of the rolling stock, and we watch the behavior, we train the AI, and then you've got, maintenance costs fall significantly, right? It's all a wear and tear thing. That translates directly to a conveyor belt in a manufacturing facility or a mining plant or a food production plant. The use of cameras originally we were using them to know what the car number plate was, but now of course we can take pictures at the wafer level, and we can identify the glue and the temperature and everything and work out precisely the optimum yield, as you've seen before, these sorts of things. We can take pictures of anything from vegetables and food contaminated products across all industries. So, but then also coming to where, you're talking about shareholders and where's the money sort of thing. But just have a think of another example. Huawei with GSMA, we won an award with Midea and one of the mobile operators. And very specifically, we went through one of the largest appliance factories, in China. And the reason this one's important is because, okay, so you're making an appliance. Well, what happens when everybody's got a washing machine, for example, or you've made the production, it's so productive, the efficiency is so high, the cost of the washing machine's $1, you can't make it. What's next? Well, how do you scale up different type of products in this manufacturing facility? But also, yes, you can become very efficient at one part of the manufacturing process, but there are many things that go on in a production company, whether it's food or cars, yes? It's not just about the process component. So we demonstrated, I think, 15 different type of use cases, not just use cases, we deployed them. And this is why we won the award. So what I'm trying to demonstrate here is if you can collect information, and I mean, you're a guy who's used to traded a lot, financial expert, and if you have the data, then you can start to analyze it. So the key is you've got to collect all the data, whether it's based on IoT or 5G or Wi-Fi 6E, for example, yes? There's some of the fundamentals, I think. And that's the reason why we went down this line of Pangu, because we wanted to put it in the cloud. If it's in the cloud and it's pre-trained, this is how we make it easy for, I'll say, even a novice, not even an expert data scientist, to be able to access it inexpensively, quickly, and without having to be a rocket scientist to get the business benefit or the economic, not the business benefit, but also the technology benefit from it.
Well, let me jump in and ask Maximilian, you were responsible for digital transformation for Bosch in, I think, 49 countries. With all of the talk about de-risking, if not decoupling, do you see the fourth industrial revolution as a unifying or a dividing feature of the world economy? Will it bring countries closer together, or will it create more national boundaries?
Well, I think it's more unifying because, first of all, if you look at the supply chains, say, remember the Suez Canal, Evergreen, everyone was stuck and thought, oh my God, can I deliver tomorrow? Because I need the parts and I don't get my parts I need currently. So I think that's the first thing where how can I prevent this in the future? What can I do? Or also energy consumption. There we are dependent. We are dependent in a lot of ways. So now you could say maybe AI, maybe digital transformation, we are not so dependent. Let's do it ourselves. So I just give you an easy example. You can now sit down, take one machine and record data for 20,000 days. One machine, 20,000 days, you collect data. So you need probably 50 years, a little bit more than 50 years, and you get your data set you need to do a nice AI algorithm. So 50 years, it's a little bit long time. So now take 20,000 of the same machines around the world, buy this data, and you need 1 day to do the same AI algorithm. So what does it mean? In the end, maybe I have to spend money to get data or good data to teach my AI algorithms, but in the end, yes, we are a little bit dependent on working together because then we can do improvements. And I think this is not, we are more collaborating in the future. And to show you how critical and crucial it is, I can imagine about our newest Europe's definition of Industry 5.0. There we said, okay, what's the goal? Industry 4.0 is great, but there are three things missing. Sustainability, because energy is coming from the wall. Where comes my energy from? So you didn't thought about this in the past so much. Then human-centric. The innovations come from the humans. So not AI is not kicking out the humans. People using AI will kick out humans. So you have AI as empowerment, not as standalone. And in the end, resilient. I think that point is much more crucial than if you do decoupling or doing something like this. How can you remain resilient? What happens if a country doesn't buy something? What happens if there's a new decision and so on? You cannot be so dependent in the future on decisions of some countries. So you need to have a flexible, adaptable, and it's not flexibility, it's more an agile environment. You don't know what happened, and because you don't know what happened, you should be really good in adjusting yourself, business model, and so on, to your new environment. So I think this is, on one of the hand, you need to be more focusing on being agile. On the other hand, you really need to work together. And just one more example, maybe from Bosch. There we work globally. So for me, if you ask me for Germany, yeah, I can answer you the question for Germany. We are doing a lot of partnerships. Also, the big companies doing a lot of partnerships where you thought to yourself, wow, these two competitors didn't like themselves. Now they're working together. Yeah, we have to team up. We have to catch on the speed. We need to fulfill our goals. And that are not just goals for EBIT or profitability. These are also goals for our countries. And if I take, for example, the topic AI, I just want to refer on the point you did before. Yes, we have some data engineer experts we put into the companies where we already recorded a lot of data, and they do an AI project thinking about, oh, what do I see? What can I learn from it? And the benefit return of invest is always below half a year. And it is making profitability up to 10% of efficiency in 1 year just by analyzing data, learning from different data sets, and developing your AI algorithm. So in the end, I would say the fruits are really low today to get benefits out of AI. And because the fruits are so low, you should work together, because in the end, if you don't do this, what will you do? You don't learn, and you cannot apply what you want to do.
Can I pick up on this point, David?
Paul, are you going into the data business?
And this is precisely why, when we have discussions in many countries, and I mean, you started the discussion, David, by saying, I hadn't been to China for so long. I went to China and, oh my God, what did I see? And that's the same thing, Max, you're saying here, right? In terms of collaboration, the only way you're going to be able to scale any of the solutions that we're talking about, whether they're focused on circularity and sustainability, whether they're focused purely on efficiency or on money or innovation, is to collaborate. One person can do one thing at one time, even you think you can multiplex it, and you can't really, yes? So the power of visiting other companies and other countries is, as you said, Max, to learn. And I think through this type of webinar, that's one of the things we're saying. You've just reinforced a lot, Max, a lot of the examples that we were quoting, whether it was in the mining sector. Drug is quite different, but manufacturing, mining, for example, these couple of sectors and the ports, we see 10 to 30% improvement. Yes, the drug one is quite remarkable. 70%. There are complications in that industry, and why it takes so long. First of all, it's very conservative, but also the collaboration bit. In the past, you had to write a research paper, had to be peer reviewed. It went all around the world. How did it go? By carrier pigeon, in a book, in a journal. Now it's all online, but it's not just online. Now you have AI algorithms that can scan through that and pick up on, okay, we'll call keywords, but at least it brings to, as you said, the person who's orchestrating all this, which is a human, to then pull all this in and say, all right, I need to tweak it that way. I need to tweak it this way. What the AI can do is improve your ability to sift through a lot of noise, or to look at things that perhaps were uncorrelated, you felt, and it's sort of like collaborative analysis. And that's really the way to scale all these things up. You know, what we do in China is very different to what we can do in the UK or in Germany or in France or Australia. Yes, cultural differences, you know, environmental differences, just the business behaviour of people, together with government incentive programs and who feels more, you know, what is more important, etc. You know, there's a lot of reasons why these things move in these directions.
Yeah, I have just
Paul,
to add one thing. Sorry,
go ahead,
David.
Matt.
Just
My
one
friend,
thing
please
on
go
that.
ahead.
Yeah, it's a nice discussion. So I have to jump on the topic. Yeah, you can do a lot of things, but one thing you shouldn't miss as a company, you need to have your processes known. Who does what? How is your information flow going? Where comes your data from? Do you have multiple data storages, or do you have one data storage, or how do you do it? What's your data quality? What are the security aspects you have? And so on. So you have to be quite aware you can do a lot of progress. So if you can do a really lot of progress if you have already set up a lot of things. But if you don't have it, then you need time. You need to collect data. You need to provide the right quality, quantity. You need to set up your correct network segmentation for IT security and so on. So I don't want to pick the next topic and to push on the next topic. I don't know what it's going to be, but if you don't start today, you cannot push the acceleration because you won't get on the street. So it means you have already to start so that you can really fastly get your benefits out of it in the end. So I would say, talking about that examples you did, yes, there are some examples where we did 80, 90% profitability in just one use case. These are special, but maybe you don't see what pre-work you did to become there, that you have just your algorithm and then you have your benefits. That's not so easy.
Yeah, this is absolutely true. The reason why we have pre-trained Pungu model. Sorry, David, carry on.
Oh, Maximilian, one reads in the German media all the time discussions of the decline of Standplatz Deutschland and German industry is in crisis and terrible things are happening. How do you feel about the state of German industry and its future? Do you think these technologies are going to make a big difference for Germany and for Europe generally as an industrial site?
Well, in the end, look at the GDP of our countries like China. It's really comparable. If you look at how much industry do you have, so manufacturing industry, in your market share of the GDP, and you see China is 32%, Germany, it's also 1/5 of Germany is just industry and its production. So this means for us, we are dependent on a working industry. China, Germany, also France, also Italy. You can take quite some of these countries where you see it is really important. So now if you take a look at United States, industry is not so important for United States. Their service is more important, or IT business and so on. So there is a difference in looking at it. And if you look at the different countries, also especially Germany, we have initiatives. We push and we strive to accelerate the knowledge exchange between our companies. There are a lot of units around whole Germany have just one goal: taking knowledge from science, taking knowledge from industry and push it to other industrial companies. So am I afraid of these new technologies, especially looking at our industry? No, I'm really happy because we are really good in Germany with giving us the insights to each other. And I think this is a tremendous point. And the other point is we are good innovators and we have good ideas, and this we had still along, and we don't lose our good ideas. Even if you take a look at IT, if you think about IT, you probably think about Facebook and whatever, but the first email, where did you send that? Who has invented the internet and so on? There you see, you need a lot of innovations, and there I think our mindset with all the knowledge exchange is perfect to gain the speed we need.
Thank you. Paul, there's a question from the audience. We've already established that digitalization means more, not less globalization. But what does that mean outside Europe? What, for example, for Africa? What do these technologies imply? I know you have a lot of experience there, and Huawei's done a lot, so I think the audience would love to hear from you on that. Your microphone is muted, Paul. You have to unmute your microphone.
Sorry, David. Yes. So the first thing I think of is when I was traveling around Africa, and they were still in the embryonic days of deploying things like 3G. Yes, but already the rest of the world was quite well down the track of 4G deployments. Just taking a simple example, and many questions were coming from governments and also operators. Do I need to go to the next G, or can I leapfrog it? Right, somewhere barely installing 3G. They certainly didn't have the entire network saturated with 3G. So I said, can I leapfrog and go to 4G? So one of the challenges there was we have to educate everybody to understand where the benefits were. And of course, you remember back in the early days of 5G, if 5G is really about efficiency, right? It's far more efficient than 4G in terms of its its spectral efficiency, etc., because of the modulation and framing and things. So the benefit there, of course, is it translates specifically down to cost savings per cell per site. So if you have a look at the biggest cost problem at a telecom network, it's really the site, the site backhaul, the site rental, and the site power. So we focus on these areas. Yes. The second area that we found was deploying things like AI, and I'll actually won't say it's full AI. Let's talk about machine learning and advanced computation and things like this, because I think AI is also very, very misunderstood. But in other countries, developing countries, they're also looking, and I think you phrased it correctly, Max, at the very beginning, and that is you're not afraid of technology. Generally, people aren't afraid. Maybe at the beginning they hear some things, at each of the beginnings of each of the industrial revolutions, because they're scared about jobs. But what we were seeing was that they were prepared to use technology in order to leapfrog, or either competition, or to benefit in other ways. And the mining sector is one particular industry that picked up on this. Take a simple example. I know it's a telecom thing, but fixed wireless access. We were promoting this thing called WTTX. Have fiber to the room, fiber to the home, fiber to the house, etc., fiber to the curb, FTT something. Well, about 10 years ago, we called it WTTX. We're using this particular block of spectrum. Oh, by the way, it's very similar to 5G. It uses a MIMO thing. But, Africa was deploying that on steroids, yes? A lot of the solar technologies that we're using and what we call these rural star products, which are very inexpensive earth stations, which include everything integrated, but also understanding consumers, understanding how much solar energy can be generated, and this little ecosystem, micro ecosystem of the cellular, just for a couple of hundred people in a village. So suddenly we saw Africans, not just Africans, but developing nations looking and saying, which technologies could we select? And do we have to go down the path of legacy that a lot of the Western countries had? So you saw a lot of micro innovation in Africa as well. The one white globe, or a Wi-Fi connected to a hamburger salesman who's pushing his trolley along the desert because he's got Wi-Fi and everybody can find him because of the location on the app. And they come there just to charge up their phone because he's got solar panels on the top. But what's he selling? Yes. So we saw a lot of these, I'll say, micro innovations. And of course, a lot of it also started with things like M-Pesa, with micro loans and micro payments. And, I borrow $1 in the morning and I go and buy the vegetables and I return $1.20, and, and I've made 10 cents and the lender makes 10 cents, these sorts of examples. So I would say, necessity is the mother of invention, of course. And I think that really happens in a lot of places. But you don't get that just by necessarily dreaming it. You probably saw something and then you figured out, how do I execute it? And that really comes back to where we started the conversation. We want to scale up deployment of 5G, fiber to the room examples, yes, or other very sophisticated technologies. We want users to understand, as Max said, what are the stepping stones in order to be able to successfully deploy an AI, yes? And you don't get that by doing things in isolation. Yep, that's very important. So,
Maximilian, you've got a great deal of experience in the developing world. Do you want to add to that?
Yeah, so maybe for Africa, I take a particular point because there we're also supporting and have the exchange with them, and what's really necessary there, we talk about high-end technology AI, There are a lot of smart guys coding something on their laptops. That's nice, but who installs the technology? Who hardwires it? Who applies technology really on the point? If something is broken, who runs there and fix it? And in the end, these are your hands-on worker who can do it. And if you take a look at Africa, they just copied, and we want to do this, they just copied our apprenticeship. So how they learn to hands-on solve problems. So problem solving, I would say, it's one of the major key competencies you need in the future to survive, to be really fast in problem solving. And that you can only do hands-on and also with experience. And also for Africa to add this means in the end, they take it from the beginning. By learning for the job, they already learn different parts how to solve their problems. And we also do this in Germany. We have our system. You're coming from the school and directly learn how to apply something. And we also change our jobs there. So there's not any more the three common jobs. There are new jobs evolving, and you have to learn really how do I adapt a database. What's the difference between time series database and a normal regular database? How do I connect it? What's behind Wi-Fi? You just talked about 5G. So should I use 5G? Should I use Zigbee? Should I use Bluetooth? Should I use Wi-Fi 6? What is the benefit? So it is always use case driven. Maybe I need an easy case, then I should do it. Maybe I have to think about interferences and it's not working so easily. So these really hands-on knowledge is a key, not only developing. Developing, I said, great innovators. That's one point. The other is solving problems in the end. This I wanted to add. And also Africa is there, not starting doing their own things. They are working closely together and also push this in the early stage of learning for a job.
Maximilian, going to your point about Wi-Fi versus 5G, I mean, there's certainly some industries where it doesn't make a big difference, but we have a question from the audience about mining. And certainly in a mine where you have a lot of heavy equipment moving around quickly, having cables is a significant disadvantage. So perhaps you could say something about the relative advantages of 5G versus Wi-Fi.
Yeah, so I said there are different use cases and different benefits. So if you talk about mining, huge distances, you want to be precise where it is. There you need, if you have a 5G network, you need to set up not so many repeater. So I call it repeater so that the audience gets it more like this. So we talk a lot about setting up an interface, infrastructure, and I think there it is a good case mining to do that. You could also do this with Wi-Fi 6. You could set up a lot of repeater. You can hardwire the repeater, but then you have your direct communication. We do this, for example, Bosch Rexroth, we're giving you the mobile hydraulics. The mobile hydraulics, we want to know, is there a problem? Do I have to change it? Do I need service? Do I need fuel? And so on. So in the end, you can do it with both, but there are benefits. The bigger it gets and the more complex it gets, probably 5G is the more easy. But if you are in your segmentation, you have one big hall with a lot of machines, then Wi-Fi 6 is the more easier way to do it because it is so standardized. You don't need a supplier. You can do it by yourself. If you are a big company, you want to do it by yourself. If you're not a big company, you maybe just more easily buy it and you don't care which technology it's based on. You just want to solve your problem. So there are a lot of aspects. And to be precise, at Bosch, we say Wi-Fi 6 solves almost every our problems we currently have. And there are some 5G cases which really make sense, but there we are. Do we want to be precise on 1 centimeter or 1 millimeter, or do we want to be even better latency times, or what is our necessity? And then I would say, looking in the future, it is an invest for the future 5G, probably. And looking at today, I would say if you have already Wi-Fi 6 in place, you can do a lot of things. Transferring it to mining, it's not so easy because if you don't have Wi-Fi in place, you should really consider thinking about, do I do 5G or Wi-Fi.
Paul, going back to the mining example, I've seen a couple of videos. Fortunately, I did not have to go visit a coal mine when I was in China, but you have a couple of projects installed which look pretty remarkable in terms of automated mining. There's essentially hardly anyone below the ground, a bunch of people sitting in an air-conditioned trailer on top of joysticks running everything. What will it take for this technology to be broadly adopted in the mining industry, where you, as opposed to a few demo projects, essentially?
Well, again, that's how we started the conversation. This is all about scaling up, right? So this is a DNA problem. Yes, this is understanding, the benefits of some of the technologies, but also it's a little bit like what's in the box and who's going to sell the box, right? So inside the box, it's not just 5G or IoT or Wi-Fi or fiber. There's an operating system. Yes, you need a provisioning system. You're in operation and maintenance. Everything needs to be in a box, right? Remember, this is a private network, and as I said at the beginning, GSM have already estimated more than 10,000 of these private networks. So some of the key components of these, the only way it's going to happen to move it at scale is probably the efficiencies we were talking about at the beginning, and that is how to package everything up. I mean, it's very clear that video uplink, yes, with some intelligence, pretty much, just to come to your point, Max, can solve almost everything, yes? Before we were putting sensors everywhere, we had to connect all the sensors. First start with wires, then we moved wireless, and it doesn't really matter which technology. But if you really want to get this stuff at scale, then you need something very simple. You want to track patients or things like this in a hospital, or you want to make sure that dispensary issues the right drugs and that each of the patients are taking the right drug. Well, you can put a whole range of complicated IoT components in there. You can have a camera, and it'll take 20,000 photographs a second or something, and it'll be analysed in 5 minutes, and it'll know precisely which drug, who took what, and it'll know what the interactions were with something else. And the reason I make this point is because we experimented in mines, we experimented in ports, and then we started experimenting in other industry sectors. Yes, and the first mines were take an existing box, existing radio, and industrialize it, make it bulletproof, make it fireproof, etc. All the intrinsically safe parts that you needed. Take a camera off the shelf and put it in those boxes. That's obviously a very expensive solution, but today you're seeing that these things are becoming, I'll say, slightly commoditized as different industry sectors start to understand it. You must remember, Max, back in the old days, we were talking to many operators, many customers, many enterprise customers across segments. And if we spoke to somebody in manufacturing 5 or 6 years ago, and we asked them about, what do you think about 5G? The majority of manufacturers said, I pretty much think I know what it's about. I know the problems I've got, and I expect this to be fixed and that to be fixed and that to be fixed. I go and talk to the same person in a hospital, and they don't understand what G is, right? They just know how to mobile phone, for example. So the ability to understand and adopt technology differs sector by sector, okay? The pandemic has probably put a few things on steroids, like we now know people can do what we're doing now, webinars online. This is an uplink requirement, yes? This is not a Netflix downlink all the time as we did with 4G. The same thing with healthcare, yes? So mine is one example of packaging a couple of core components and then being able to make them almost a commodity so that they can be deployed. But today, you've got 5,500 mines of all variations just in China. You probably have 50,000 outside China, and we don't have 50,000 salesmen from all the operators going knocking on all the doors to be able to have this one by one piecemeal. So, this thing needs to be like a sausage machine for you to be able to deploy it at scale, whether it's in a mine or a port or in a hospital or even in a university. So.
Let me ask a question which is much on my mind, much in the news. As you know, there has been an effort by the United States to limit the power of the computer chips, which can be sold to China either by the United States or with American intellectual property. This has been a huge source of contention. How important in all of these systems is the raw computing power? Does it make a great difference if you're using the NVIDIA GPU with high clock speed, or the scaled down one that can be sold in China with lower clock speed? Is raw computing power an important constraint on what you're doing?
So is it going to me the question, or to Paul? Because I could also answer a part of it.
Oh, to both of you, please.
Why don't you start?
Okay. Then I start with the topic computing power. So think about coding. If you take a look at C or Python, different programming languages, Python is much more energy consumptionable as C. Why is it like this? It's because of the way of coding, and it's a more proper programming language. So in the end, there are a lot of ways how you can reduce necessary computing power. So it is not everything you have to solve in every 1 millisecond. So another thing, for example, if you talk about sensors, you can get the data from your temperature, for example, from the room. You have your oven, it should heat, and then you take the temperature, and you could get the value every millisecond. Do you really need it every millisecond, or is it okay if it says, oh, it's now too cold or it's too hot? So the way of programming something is also important before you think about the computing power. If you think about computing power and AI algorithms, yeah, there you have big sites where we have just computer farms with a lot of computing power, because we need to get a lot of data in a short time processed. For example, deriving a derivation, getting a deviation of some data points. Then you probably need big computing power. But if you go more down to the edge level is where the machines are, where the assets are, and so on. There it is not so necessary to have the highest computing power, but you should think about which decisions and calculations do you need on the edge level. For example, health issues. So I don't want that I get a electricity problem there, that I have safety topics. So every calculation for the safety you should do on the edge, like in your car. There you have your edge system computing. And for all the parts which you don't need to have it today, but you need it tomorrow, then you should put it more on the cloud computing, big data computing power farms. So I would say it would be more smart thinking about what you need today. There you need the computing power, and what you need immediately, and you should think about what can I do during the day, and I don't need it in just 1 minute. It's okay to get it in 2 hours. Then you don't need the highest computing power.
Yeah. So David, simple answer: horses for courses. It's application specific. But the other way of answering it also is, what's the target? Because if you think about, just coming to the second last point you made, Max, about let's talk about the sustainability component, or the circularity, yes, then you're now going to pick the most efficient way in order to do it. So if you're power constrained, generally you don't have higher CPU compute capability with less energy, right? It's a trade-off. So if you have something that's very, if power is the limitation, then you probably want a different type of programming language together with a different type of application-specific semiconductor, yes, whether the memory is included or not. That might also direct you to whether or not you're going to be using low-powered Bluetooth, Wi-Fi something, or a 4 or 5 or G or whatever, or narrowband IoT and LTM, all of these components. So it's not just about saying, I'm going to deny you X and Y. I mean, it's like saying, I'm going to deny you a 5 nanometer chip. Well, in a 2.5 ton vehicle with autonomous driving, it doesn't really care. Yes, those sorts of things. Yes, so you have to think about the application specifically, and then what can you innovate around. But just remember, if you're denied something, right, it doesn't matter what it is. If you're resourceful and you have the ability to source resources, other resources, and you spend enough time thinking about it, you can engineer things in many different ways, yes? But just to say I'm going to throw a lot of compute power at something doesn't necessarily...
What I hear from you is that in an atmosphere of commercial tension and technology conflicts, the underlying benefits of digitalization are likely to overcome all of these barriers and lead to more international cooperation and more exchange. Is that the conclusion that we should draw?
That's fundamentally what I believe, and I think that's what you also mentioned. It's about, collaboration you'll always see that if I collaborate with you, then I will get, it's not about win-win. I need you to achieve my targets and you need me to achieve your targets, right? And unless we're absolutely both the same competitor, but we never are exactly, are we?
This is incredibly important. I'm an economist, you're a technologist. Economists debate about the relative merits of free trade versus protection. And what you're telling me as technologists is that there is an underlying dynamic which comes from the technology itself, which transcends the stupid way we economists are taught to think about these things. So
I'll put it a different way, David, before you finish it off, I'll put it a different way, because I think you mentioned it, Max, about standards, yes? And we all work together on standards. So if Max is coding, Max wants to push his version of something to make it a standard, and I have a different version, maybe we all fight, but at the end of the day, one of us is going to look at the other and say, that's pretty brilliant, that. And in the end, because we're all engineers, we're all geeks, right? Technologists, I'll say. Then we're probably going to head down the line and say, yeah, that's the better technology, despite which country we come from or which company we're working for. Because if we do that, you might get a short-term benefit, but in the long term, the standard will evolve into something that's beneficial to that industry sector.
Yeah, finding the best suitable solution. And what you already said, you need a target. If your targets are similar, you should work together, because you can learn from each other and you can get the right application and also the right way to drive this. And I would say if you have completely different targets, maybe then it's another point. But if you look at the world, we all want to be efficient. We all want to be driving our new developments. So their working together is key, and I want to push this also in the future. And I think I'm not the only one. We see Paul is also one like this, and like we techies, we say in Germany, we are more focusing on a good solution. Then you need economists like you thinking about, can you pay that solution? Is this really economic to do this? Maybe it's not the best way, but it's the cheapest way. And then in the end, we get a good solution.
Gentlemen, this has been enlightening for me, I'm sure, for our audience. Asia Times thanks you profoundly. This has been great discussion. I've learned a lot. I think our listeners have too. Many thanks again. Hope to see you both again soon. With that, I'm closing the webinar with thanks to the speakers and the audience.
Thank you. I guess since it's only you and me left here, Max, we're probably finished.
I think we are finished, yeah. I don't know if we're live anymore, so.
I don't think so. It's after 11, yes. But I'd love to meet you in person. So perhaps my next trip to Germany would be good to catch up.
Yeah, so where are you located currently?
Between China or in Asia generally, but I travel quite extensively.
Yeah, November, I'm going to be in Shanghai. Maybe we can meet up. So, okay, so let's get in touch.
I'll probably be in Germany in September or something. So that could be also an opportunity.
Okay, perfect. So have a nice day. Nice to meet you.
Pleasure. Bye-bye.